everybody, it's the whole universe. Hope of this fine, I'm Rashman who brings forward from experience, and today we're gonna discuss about 4 different tasks that we solve in machine learning. Coming up, as they say. Okay, first, clustering, classification, regression analysis, or it is predicting of the target function by empirical data, and the fourth, it is our dimensionality reduction, linear dimensionality reduction and non-linear dimensionality reduction. Let's start from the first. It is clustering. Clustering, it is when we cluster or group the objects in the specific sets or groups or clusters. Actually, similar will be in one cluster, similar will be in another cluster. And to these clusters, they are different to each other, they are dissimilar to each other. Okay, and we use different types of algorithms, such as k-means, k-means plus plus, k-means sharp, robust, k-means plus plus, dbscan, dbscan, kurt, chameleon, clara, clarans, fast color, fast colorans, fast PM1, fast PM2, YPM, DMVCJ, DMVSSC, DMVCVAE, RCC, RCDR, CDR-SGD, DRC, DEC, COR, HOMM, O2 MAC, fuzzy C means, STING, AGNES, agglomerative nesting, Diana, divisive analysis, depict, and others, GMM, EM, and etc. Okay, it is clustering that we have, and it is actually collecting data in the specific groups that are similar, that objects in these groups, they are similar to each other, and two different clusters, they are dissimilar to each other. We use different types of metrics, such as Euclidean distance, squared Euclidean distance, Manhattan distance, Minkowski distance, Chebyshev distance, and also cosine similarity and Kullback-Leibler similarity, or divergence or dissimilarity. Divergence, actually, it is the distance, Kullback-Leibler divergence or distance. Okay, it is about clustering, and the example of clustering, it will be that you are, for example, in the school, somebody is playing Genshin Impact, somebody is playing also Brawl Stars, and someone is playing Minecraft, and you can cluster people by their interests in game industry, in the video game industry, and their preferences in different games. Okay, next, classification. Classification, that's when we get something as inputs and we label these inputs as objects to different classes, or we give to them specific identifiers or indices or specific labels, tags, and etc. Actually, for example, we have this one, yes, and it is, we don't know what is it. Maybe it is the cylinder, or maybe it is deodorant. Actually it is deodorant, yes, and it is a specific kind of labeling of the data, marking of the data, or identifying the data and giving them specific identifier of the specific class. It is classification. Also, about classification, we have different types of algorithms: k-nearest neighbors, also naive bayes classifier, XGBoost classifier, cat boost classifier, light GBM classifier, and also it could be decision trees, random forest, and artificial neural networks, and support vector machines, and multi-class support vector machines, or one-class support vector machines for outlier detection. And in outlier detection, we use also Z-score, IQR, and DADA, ODIN algorithm, and also LOF, COF, local outlier factor, connectivity-based outlier factor, and others. It is for outlier detection task. Sometimes outlier detection, it is a binary classification task. Actually, we have different types of classification types for multi-class and also for one class. We have logistic regression. This is the specific equation of that is similar to this formula: 1 over 1 plus e to the power of minus x. It is actually the specific equation, the specific formula that we can use to find logistic regression. It will be this type of it will be S letter, yes, S letter, specific S letter graph or S letter plot that you can see on our Cartesian coordinates. Okay, it is about our classification task, and we have logistic regression, multinomial logistic regression, and etc. Actually, logistic regression is binary, and multinomial logistic regression, it is 1, 2, and 3. It is multi-class actually. Okay, it's classification. It is for labeling the data, and also we have different types of artificial artificial neural networks such as RNN, DNN, CNN, HN, KN, P, LSTM, AE, VAE, SAE, DAE, GAE, GAN, JAN, GNN, DFF, FF, DBM, BM, RRBM, NTM, ESN, ELM, GRU, MLP, and etc. Actually, how can we describe them? How can we describe them? It is, for example, recurrent neural networks, the deep neural networks, convolutional neural network, convolutional neural networks, deconvolutional neural networks, feed-forward, deep feed-forward, gated recurrent unit feed-forward, as I said before, neural Turing machine, extreme learning machine, echo state network, autoencoder, relational autoencoder, denoising autoencoder, sparse autoencoder, and others, multi-layer perceptron, long short-term memory, and others. Okay, it is about our clustering and classification tasks, and inside of the classification we have outlier detection task. Also, we have predicting of the target function by using empirical data, or shortly regression analysis, or more shortly RA. RA, yes, it is written as 2 letters. Okay, and regression analysis, we have linear regression, nonlinear regression, also polynomial regression, stepwise regression, robust regression, and rich regression, different types of algorithms. And here, what can we use in this field? We actually... How do we work with it? How does it work? Actually, we have the specific data and we predict what's the function that shows this law of the moving of the data, dynamical move of the data, kind of time series data, we can describe it, and it is data, and we see that the function will be this way. Yes, if it will be on 2D illustration of on Cartesian coordinates, yes, and actually if it will be this way, then we can predict that it is here. Actually, we have linear regression. It is the equations of beta times x plus beta 0, or it is linear regression. Also non-linear regression, this specific equation divided by another equation, actually numerator, denominator we have, and also we have polynomial regression. It is the equations of the type such as beta 0 times x to the power of 6 plus beta 1 times to the x to the power of 5 plus beta 2 times x to the power of 4, and etc. It is actually a polynomial equation. And also we have stepwise regression, robust regression, rich regression, and etc. Robustness, it is when we are strong and powerful to some deviated data and outliers that we have inside of our distribution. Okay, and it is our regression analysis. It is almost the same as classification, but actually we can predict, we can forecast, we can guess what will be the next step, what will be in 1 year, in 5 years, so what will be our results in this period of time, actually. Okay, it is about our regression analysis, and we can interpolate function or extrapolate function, approximate actually, and also interpolation, extrapolation, and also approximation and regression analysis. It is different. They are different terms, and we actually can use them as synonyms, but they are dissimilar to each other. They are not the same. Okay. Next, also we can use L1 and L2 regularization when we have underloading and overloading, overfitting, underfitting. Yes, it will be correct way to say it. We have overfitting when we have data, yes, and we have the function that is goes kind of this way. And also we can see underfitting. It is when we have data this way, yes, and actually the function will be linear, but actually we can see that it is non-linear, yes, but actually non-linear, it is the specific set of linear equations. Okay, and we use different types of L1, L2 regularization with norms, and we use them to kind of make the process to show the correct way to go, yes. Okay, next, it is the dimensionality reduction, linear dimensionality reduction, non-linear linear dimensionality reduction, what is it? It is the specific task when we reduce our dimension number. For example, we have 3D and we decrease it to 2D, or maybe we have 2D, we decrease it to 1D. 2D it is this way, and 1D it will be only the line, yes? And it's the same thing when we have 600D to 200D, we can decrease it, yes? Or maybe we have length, width, height, depth, RGB, RGBA, HSL, HCL, HV, HSV, CMY, CMYK models of colors, and also we have specific features such as age, gender, and also city and language that people speak in these cities and countries and the places and etc. Longitude, latitude, altitude, and other features. And actually, we want to use only the longitude, latitude, and altitude, and we can decrease others, and we don't need them actually. Other features. It will be the process of reducing dimensions, and we can use different types of algorithms: PCA, ICA, fast ICA, LDA, NMF, TSVD, SVD, TSNE, FA, EFA, CFA, Grand Prix, KPCA, PPCA, and etc. It is actually different types of algorithms that we use in dimensionality reduction. Also UMAP, uniform manifold approximation and projection. Also we can describe others: PCA, principal component analysis, independent component analysis, linear discriminant analysis, non-negative matrix factorization. Also UMAP, uniform manifold approximation and projection, and TSVD, truncated singular value decomposition, T distribution stochastic neighbor embedding, FA, factor analysis, and others, Grand Prix, exploratory factor analysis, and others. Why do we use it? Why should we kind of cut the dimensions? Why should we do this? To represent, to visualize, for the presentations, for example, that you want to show as the review, as the survey, as the specific kind of report for your company, or etc. And also we can use it to use it for the specific research. Yes, we for example ask people on the streets about their preferences in music. What do they like? Pop punk, or specific rock music, or Hans Zimmer, Ludovic Einaudi, or Iruma, and etc. And we can ask them what do they prefer more, and we need only the data. Maybe for the age, we want to see the correlation between the age and also their preferences in music. In this case, we don't need something like cities where they live or something else. Actually, yes, it will be nice to use this data, but it will be more optimized when we will use only the data that will be available for us, that will show the most impact will be of this data. So it will be correlated the most with our goal. So that's why we have principal component analysis. It is principal kind of what will be the first, yes, what will be the main values, the main factors, the main things that are valuable for the specific goal or task, or etc. Okay, thanks so much for watching this video. Today we discussed about clustering, classification, clustering, classification, regression analysis, dimensionality reduction, and also regression analysis. It is our predicting of the function of the target function by empirical data. Thank you a lot for watching. It was nice to talk to you, and leave in the comment section below what do you like and what do you want to see more in the next video. It will be really interesting. It was the nice practice for you of English. You listened a bit. If you are a machine learning engineer, then you can kind of increase your vocabulary and also your understanding of the topic comprehension in this field in English. So thank you a lot for watching. See you next time. You're a nice guy, a girl, and improve self daily. Yes, improve self daily. Bye.